Okay, we're going to work with arc, central angles, and inscribed angles. The tools we're going to use are the inscribed angle theorem and the inscribed angle corollary. The theorem basically tells us two things. One thing is something we already know from the beginning, kind of like a definition, that the arc from A to B, like 2 points, is going to be the same measure as the angle that comes from the center of the circle. So that angle is called central angle. So the central angle is going to have the same measure as its corresponding arc. Now, what the inscribed angle theorem tells us is that the inscribed angle, which is a little bit different than the central angle, okay, this red one, the inscribed angle is going to be half of the central angle, which in other way, it's kind of like saying that the inscribed angle is half of the arc. If the arc is 20 degrees, then the central angle is going to be 20 degrees too because they're equal. But the inscribed angle is going to be only 10 degrees because it's half of this one. Now, the inscribed angle corollary gives us another different idea. That if I have several inscribed angles and they all share the same arc, that means that all of them have the same measure because it will be half of AB in this case. Like the first inscribed angle will be half of the arc AB. The other ones, because they share the same arc, they will also be half of the same arc. So they all have the same measure. This inscribed angle will be equal with the other one and equal with the other one. Okay, like the measures of them are going to be equal. The angles are going to be congruent in this case. So those are the two tools that we're going to use to solve some algebraic exercises with angles. Okay, the first one will be to find the measure of x. Okay, so I'm trying to find what is the measure of angle x. Angle x is an inscribed angle, which will be basically half of its corresponding arc. This arc has a measure of 160 degrees, and half of 160 will be 80 degrees. Okay, so that will be the measure for x. X will be 80 degrees, and that's it. Okay, I used the inscribed angle theorem that is basically half of the central angle or the arc, because remember that the central angle and the arc are basically the same thing. Okay, they have the same measure. Yeah, they're not the same thing, but they do have the same measure. Okay, this other exercise kind of like make things backwards. Okay, I already know the inscribed angle. What I'm looking for is the arc, the measure of the arc. Because the inscribed angle is half of the arc, that means that the arc will be double of the inscribed angle. So with that idea in mind, I can easily say or tell that y will be 82 degrees, which is double of 41. And that's it. Now let's see this one. This one is a little bit more complicated. I need to find 3 variables, x, y, and z. Okay. Not necessarily I need to find them in the alphabetical order. The goal is to find each one of them. I'm going to find the one I can find. Okay. Like for example, if you notice this angle of 45 degrees. Okay. If you check the endpoints of that angle, it kind of like shows me that the arc, the corresponding arc of that inscribed angle of 45 will be z. So z is basically the double of 45 degrees. Z will be 90 degrees. Okay. Now, another thing you could notice is that 45 degrees shares the same arc as x. Okay, like the arc of z is the same arc for x and also for 45. Because they share the same arc, then I know that 45 and x are congruent. Basically, they have the same measure. So x will be 45 degrees. Using the corollary, I know that 45 and x will be equal. Another way to find this answer will be using z also. If I use the theorem itself, I know that z is 90 degrees, so x is going to be half of 90 degrees, which is 45. Now, what about y? Y is not connected to any inscribed angle or central angle. So how can I find y? In order to find y, you need to think on the entire circumference. The entire circumference is basically 360 degrees. So all I need to know is these other pieces, what do they give me in total? And what's missing will be what will be the measure for y. So I have 50 degrees in here, which will be from this point to this one. I have 70 from this point to this one. So far I have 120 here, plus the 90 degrees of Z. That will give me 120 plus 90, 210 degrees. So how much is missing for 360? That will be the answer for Y. All I need to do is subtract 360 minus 210. And that will give me that Y equals 150 degrees. That's how you find those things. You use the theorem, the corollary, and sometimes you need to add and subtract based on the entire circumference, which is 360 degrees. Okay, this other exercise, it's a little bit different because in this case, for example, the 30 degrees, it's not, it doesn't have the same arc as X. The arc for X will be 100 degrees, okay? The arc for the 30 degrees will be Y, and Z will be a central angle with the same arc Y. So like those are the each one of the concepts that I'm going to be working with. So with that in mind, I know that, for example, the arc for X is 100 degrees. So X will be half of that arc because X is an inscribed angle. So X will be 50 degrees. Okay. Now, Y is the arc of 30 degrees. Remember that 30 degrees is an inscribed angle. So 30 degrees is basically half of Y. That means that Y will be double of 30 degrees. The double of 30 degrees will be 60 degrees. And what about Z? Z is a central angle. Remember that the central angles are basically identical. The measure of them is identical to the measure of the corresponding arc. So in this case, Y and Z are equal. So Z would also be 60 degrees. Okay. I'm using the ideas that were presented in the beginning, okay? Like the central angle, which is the blue one in here, is going to be the same measure as the arc, the corresponding arc, while the inscribed angle is only half of it. Okay, let's see another exercise. So in this case, I have to find X, Y, Z, and W. So what can I do to find those angles? Okay, I need to identify which ones are inscribed, which ones are arcs, and how are they corresponded one to another one. Like for example, 45 degrees is an inscribed angle, and the arc of 45 degrees is Y. So with that in mind, I can easily find Y. Y will be double of the inscribed angle because the inscribed angle, the 45, is half of Y, half of the arc. So the arc is going to be double. So I know that Y will be 90 degrees. A moment. Okay, so in this case, I have that Y will be 90 degrees. Y equals 90 degrees. Now, what about W? W is the inscribed angle of the arc 147 degrees. So the inscribed angle, remember, is half of the arc, or the central angle. In this case, I don't have a central angle, but I do have the arc. So the inscribed angle W will be half of 147. So W will be equal to half of 147. Half of 147 is 73.5 degrees. So that will be the measure of angle W. Now, what about angle Z? How do you find angle Z? Well, to find angle Z, you need to remember that, look, this arc in here is not connected to any inscribed angle. So I need to think on the circumference. Okay, I have 147 degrees in here, 110, and 90, which is Y. Okay, variable Y is 90, so if I add 90 plus 110 plus 147, that will give me 347. 110 plus 90 plus 147, that gives me 347. How much is missing to reach 360 to complete the entire circumference? That will be 13 degrees. 13 is what's missing to complete 360. So variable z will be 13 degrees. Okay. Now, how am I going to find x? Okay, to find x, I'm not going to use, in this case, the processes of each one of these, either theorem or corollary. What I'm going to use is an older idea of what is a linear pair. Okay, that's the idea I'm going to use. Okay, so I'm going to focus on finding this other angle, the one that is not shown in here. Okay, we could even give that angle a name, or just put angle. Okay, that angle that I'm looking for, if you notice, is part of a triangle. Okay, I have 45 degrees in here, I have W, which is 73.5, and the angle. The sum of them has to be 180 because I have a triangle in here. So 45 plus 73.5 would give me 118.5. How much is missing to reach 180? That will be 61.5 degrees. Okay, so that is the angle that I have in this part in here. Now that angle with x, they form a linear pair. Okay, and what do we know about linear pairs? I know about linear pairs that if I add both of them, I get 180. So that's how I'm going to find x. Which number added to 61.5 is going to give me 180? That will be 118.5. How do I get that number? Subtracting 180 minus 61.5. That gives me the angle for x, which is actually the sum of these two, because x is an external angle. So like, if you kind of like know the process for external angles, it's just adding these two. But the entire process we used was basically triangle angle sum theorem. This plus this missing angle is going to give me 180. So I find this angle, and then with a linear pair, I find x. And that will be it. That's how we use each one of these ideas to find angles, and mainly using inscribed angles, central angles, and arcs.